Hi, in this video we're going to talk about basic probability and concept of probability. So in mathematics we recognize something called an event, and this is something that can either occur or not occur, and you measure probability of that event happening, which measures the likelihood of that occurring. We measure probability as a number between 0 and 1 inclusive, and this gives you a chart that should give you a pretty good idea what we have. So since we start from 0 and go all the way to 1, this is the range of values. When the probability is 1, this is something that will definitely happen. When it's half, it's going to have even chance of happening, not happening. So anything towards 0 is going to be less likely to happen. Anything towards 1 is going to be more likely to happen. So probability 0 is when an event is never going to occur. So here's an example. What's the probability that next February is going to have 30 days? That's going to be 0 because this is not, oops, I apologize, this is going to be 0, not ever going to happen. What's the probability that the sun will rise in the east tomorrow? The probability of that is 1 because that's exactly what's going to happen. We're not going to look at any apocalyptic possibilities. We're going to consider the things that are going to be fine, and the sun will rise tomorrow and the day after tomorrow, and so on and so forth. Alright, let's take a look at something called theoretical probability. So theoretical probability of an event is calculated as the number of favorable outcomes divided by the total number of possible outcomes. One of the simplest things with probability is flipping a coin. So when you flip a coin, there are two outcomes. You can either get heads or tails. So what's the probability of getting heads when you flip a coin? Well, you have one way this is going to happen over two total possibilities. So it's 1/2. Probability of getting tails, one way this can happen divided by two total possibilities. To make it a little more interesting, you can consider a situation when you flip two coins. What can we have then if we have two coins? So with two coins it gets a little bit more interesting because you can have tails and tails, you can have tails heads, you can get heads tails, or you could get heads heads. So that's 4 different possibilities. So we try to see a probability that we're going to get at least one tail. Let's see, this has at least one tail, this one has not that one. That would be 3 divided by 4 total possibilities. What's the probability we're going to flip two coins and get heads on both? There's one way that can happen, divided by 4 total possibilities, so it is 1/4. Alright, let's move on. So things can get a little bit more interesting when you deal with a die, a standard die that you often use in various board games, numbers 1 through 6. So we have 6 possible outcomes, 1, 2, 3, 4, 5, 6, and what's the probability that you roll a die and get a 2? Well, there is only one number 2 on the die, and there are 6 possibilities total, so 1/6. What's the probability you get a 5? Well, there is only one number 5 on that, and you still have 6 total possibilities, so that's going to be 1/6. Just as well as number 2. An even number. How many numbers are even? Actually, let me write this here. These are all our possibilities for a die. 1, 2, 3, 4, 5, 6. By the way, I want to make this clear. It's a common misconception. The word die applies to a singular when you have one. Dice means plural, so you can roll 2 dice. So, an even. We have 3 possibilities that are even, 2, 4, 6, so that's 3, still over 6. We simplify if possible, that would simplify to 1/2. What's the probability you're going to get a prime number? So out of those 6 numbers, what numbers are a prime? It's 2, 3, and 5. So you have 3 possibilities, still over 6, and you can also simplify that to 1/2. What's the probability you're going to get a multiple of 3? Well, multiples of 3 are what numbers? That's 3 and it's 6, only 2. And still over 6, that's going to simplify to 1/3. What is the probability you roll a standard die and get an 8? 0. Not going to happen. Alright. Well, it's a little bit more fun with a die because you have more possibilities here, more things to consider. But it gets really good with cards. They often discussed in probability because they have provide a lot of different variety of things. So some people don't know what cards are. That's why I'm showing this here. I'm going to talk a little bit about this. So what do we have? Cards, our standard deck has 52 cards. They're divided into 4 suits, top to bottom: diamonds, hearts, spades, and clubs. Every suit is going to have the same set of cards, which is going to be the same 13 cards: 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and an ace. Diamonds and hearts are red, clubs and spades are black. Also we have cards that are called face cards. Those are cards with faces: jacks, queens, and kings. Alright, let's take a look at some probability question. So a card is randomly dealt from a deck. What's the probability that it's going to be a king? Well, a deck contains 4 kings, and there are 52 cards total. This can be simplified to 1/13. What's the probability you're going to get a 5? Well, you have 4 5s, and that's going to give you 1/13 as well. What's the probability it's going to be red? Half of our cards are red, that's 26/52, or you can just realize that it's actually going to give you half. What's the probability it's going to be a spade? Well, spade is one of the suits. You have 13 of each. 13 divided by 52, which is 1/4. What's the probability of getting a black face card? Black face cards, that is jack of clubs, jack of spades, queen of clubs, queen of spades, and king of clubs and queen of spades. That's a total of 6 cards like that, still over 52. These can be simplified, divide top and the bottom by 2. It's going to give you 3/26. A red queen. How many queens that we have that are red? There is a queen of hearts and queen of diamonds. That's 2 of them. Divided by 52 gives you 1/26. A numbered card. Numbered cards are all cards with numbers. You have 2 through 10 in each suit, which is 9 cards. A total of 9 times 4 is 36, so it's going to be 36/52. This can be divided by, both top and the bottom can be divided by 4. It's going to give you, what are we getting here? 9/13. Queen of spades. It's only 1 card like that. So 1/52. Probability that you get a yellow card. No yellow cards in the deck at all, 0. Alright, moving on. Sometimes we deal with spinners of different sorts. So you have this spinner, it has numbers 1 through 8, and it has sectors colored differently. So what's the probability you're going to get a 4? Well, first of all, there are 8 possibilities here, so everything is going to be over 8. A 4, there's only one 4 here, which is right here, 1/8, and that's going to be our answer. What's the probability it's going to be an even number? So half of them are even. 2, 4, 6, 8. 4/8. That's going to give you 1/2. What's the probability it's going to be blue? There are 3 sectors here that are blue, so 3/8. It does not simplify. What's the probability the number is going to be prime? Prime numbers are 2, 3, 5, 7. That's 2, 3, 5, 7. That's 4 numbers. So 4/8, which is a half. What's the probability it's going to be yellow? We have 2 sectors here, over 8, which is going to give you 1/4. Alright, now next thing we're going to talk about something called experimental probability. So experimental probability is something that you use when you can't really use theoretical probability for various reasons. And we usually have some kind of data collected experimental probability is often used in sports when they try to predict performance of a particular team or a particular athlete in a given situation. So what do we have here? Jimmy's practicing 3-point shots. Out of 20 attempts so far, he made it 12 times. What's the probability he makes it with the next attempt? So it's based on Jimmy's performance. His probability is going to be 12 over 20, which can be simplified to 3/5, and it's going to be our answer. So his probability is going to be 3/5 that he's going to make it with the next attempt. In example 7, a student council surveyed 50 students about their preferred movie types. Each student could choose only one movie type as their preference, and the table shows the breakdown of that. So first of all, what we need to know here is what is the sum of all that, because we are going to divide by that. So it's going to be 13 plus 15 plus 9 plus 5 plus 8. It's going to give us a total of 50, just to verify, because it says 50 and everything needs to add up to 50. So what is the probability that a randomly selected student prefers comedy? Well, comedy would be probability that comedy is going to be 13 over 50. That does not simplify. This is going to be the answer. Drama. Well, you get the idea. It's going to be 9 over 50. Also does not simplify. Sci-fi. So what do we have? We have 8 divided by 50. This one can simplify. We can divide both top and the bottom by 2. It's going to be 4 over 25. Remember, most of the time you're going to need to simplify your answers. So if they're decimals, you're going to need to make sure that the decimal, if they're fractions, you're going to need to make sure that fractions are in the simplest form. Alright. Last thing we need to talk about is something called a complement of an event. So as we already know, any event can either occur or not occur. So the probability of a complement is the probability of that event not occurring. So when you want to talk about finding the probability of event not happening, it's 1 minus the probability of that event happening. So if you have a standard die, you roll once, what's the probability of not rolling a 4? So it's going to be 1 minus probability of rolling a 4, which is going to be 1 minus the probability of rolling a 4 is 1/6. So you got to do 1 minus 1/6. I hope you can do this math. The answer is going to be 5/6. Another way you can approach this problem is you can say, okay, if I'm trying to see the probability of not getting a 4, how many different ways can this happen? Well, I can get any other number except 4, which you have 5 of them, and that's going to be the correct answer. All right, but I still want to use the formula because I want to make sure you understand how it's done. What's the probability that a randomly dealt card from the deck is not a queen? So it's going to be 1 minus the probability of getting a queen, which is 1 minus, there are 4 queens in the deck, divided by 52. So it's going to be 52 over 52 minus 4 over 52, which gives us 48 over 52, which is going to give us 12 over 13. What's the probability of not getting a diamond? It's 1 minus probability of getting a diamond. So it's going to be 1 minus diamonds, you have 13 of them, divided by 52. So it is 52 over 52 minus 13 over 52, which gives you 39 over 52, and it simplifies to they're both divisible by 13, which is going to give you 3/4. Not getting a face card. So 1 minus the probability of a face card. So 1 minus. How many face cards do we have in the deck? There are 3 per suit. You have a total of 12 of them. 12 over 52. So it's going to be 52 over 52 minus 12 over 52, which is going to give us 40 over 52, which is going to give us 10 over 13. Okay? And this is how it's done.